Example number 1. So 1000 is 10 power 3. Convert to logarithm form, you write log 10, log base 10 of 1000, the result is 3. Okay, so the second one, write log, what's the basis? The base is 3, the power, the number is 5, the power is 1.46. Okay, very. We just keep going. I know you're very fast. So you write log, what's your base? 2, what's the number? 16, the result is 4. Log, what's your base? 10, what's the number? 30, the result is 1.48, right? This is 48, right? We say index notation, sometimes they say exponential form. Exponential. I think your textbook call it exponential form. But it's the same thing as index notation. Yeah, so we write 2 power 8 as 256. Now whether you write 2 power 8 equals 256 or 256 equals 2 power 8 is the same thing, either way. So this is 10 power 1.6 equals to 40. Okay, now next one, here we write 6 power 3 is 216, 10 power 1.72 equals 52. Alright, simple, right? So now how do you evaluate without using calculator? We let this be x. Yeah, this in logarithm form we can change to index form. Now remember, when you write index form, write 9 power x equals 27. Yeah, 9 power x equals to, 1 over 27. 1 over 27. And remember, in the previous chapter we've done something like this, right? 9 is 3 power 2. 27 is 3 power 3. So when I bring it up, it's 3 power negative 3. Fair enough. When I bring it up, it's 3 power negative 3. So 2x is negative 3. X is negative 3 over 2. Okay, the second one, again, I let this be x. So 4 power x is 2 sub 2. 4 is 2 power 2. This is 2 power 1. And this is 2 power half. So when you put it together, it's 2 power 1 plus half is 3 over 2. So can we just compare? 2x is, you learned this before, right? Remember, sub means, I start off by writing this, let this be x. So this is 8 power x equals to 32. 8 is 2 power 3, 32 is 2 power 5, 3x is 5, x is 5 3. Now the second one, if I let this be x, square root 3 power x is 9. Now square root means power half. So this is 3 power half x. 9 is 3 power 2. By comparison, x is 4. Okay. Again, we change to index form. You're finding the base. You see, previously your base, your x is a power here. Now x is your base. So we write x power 5 over 2 is 243. To find x, what I do? 243, I must power 2 over 5. This one when you bring over is power 2 over 5, right? And you've done something like this before, right? Now you can actually use a calculator. It's not illegal. But if you can remember, 243 is 3 power 5. I power 203. I cancel it, I get 9. Yeah. Although this part you can use a calculator, no problem. So next one, x power negative 2 is 49 over 64. Now guys, what's the meaning of power negative? Power negative means 1 over, right? So this is 1 over x power 2, 49 over 64. You can catch out working. I just invert it. You can actually jump from here to here. When I invert, this is positive. This one upside down, 64 over 49. When you square root, you get 8 over 7. Yeah. Okay. This one, x power 1 over 4 is square root 2. Now, to find x, I must power 4. Now, if you cannot see it, square root means power half. But when I bring the 4, this power 4 here, so it's 2 power 2. 2 power 2 is 4. The second one, x power negative 3 is 216. Power negative 3 means 1 over 3. So as I invert, this becomes 1 over 216, right? Yeah, and I can cube root. Guys, cube root 1 over 6. cube root becomes 1 over 6. Last lesson. Yeah, we stop until example 4. So today we do example 5. So number one, you're going to change from logarithm form to index form. That is, x is now 5 power negative 2. X is 5 power negative 2. Now 5 power negative 2 means 1 over 5 power 2. What is 5 power 2? 25. Okay. The second one, x power 3 is 16 power 12. Go. Now here we can cancel 3 and 3. X is 16 power 1 over 4. Now we know 16 is 2 power 4, right? Yeah, so you can cancel it. Answer is 2. By the way, 16 is 2 power 4. So 16 power 1 over 4 is 2 power 4 bracket 1 over 4. Answer is 2. Okay. The first one, we say that x is a number, square root 7 power 6. Square root 7 means 7 power half. When you power 6 is 7 power 3, which is 3 4 3. Okay, the second one is x power 2 equals to 3 power 4. Now, you know, we can actually cancel this and write this as 3 power 2. You can cancel because if you bring over, it's over 2, right? So x. Okay, guys, before we talk about example 6, let me talk a little bit about the value of logarithm. So we know that in logarithm, yeah, let's recap this. We talk about a number, let's say 10 power x equals to y. So if you write in logarithm form, log base 10 y is now x. Okay, so now let's just look at the possible values of x. Now if you put on the number line, the smallest value of x that you can, okay, let's talk about the largest value. The x value here can be 1, 2, 3, 4, and so on. In thousands, say 10, 100, 1,000, and so on. And the largest value ever, we still say as positive infinity. As we move on to the negative side, so this will be negative 10, negative 100, and so on, and negative infinity. So picture this, for different values of x, I'm going to sub in and find the values of y. Okay, so for example, when my x value is 1, my y is 10 power 1, right? So the log of base 10 of 10 is now 1. If I run logarithm form, this is what I'm getting, right? So, okay, understand? Now, if x equals to, say, 10, let me just use 2. So your y will be 100. So log base 10, 100, the result is 2. So just imagine if I extend the value of x all the way to infinity. So when x equals to infinity, y is 10 power infinity. Now we know that anything power infinity is still infinity. So log base 10 infinity equals infinity. Now this is of course this is how does it, we don't write like this, okay? So just so you know that your y can take any value from here to infinity. But let's talk about negative now. So imagine if my x is now negative 1. So we say log base 10 negative 1, right? This is x. 10 power negative 1 is 1 over 10, 0.1. If your x is negative 10, log base 10, this would be negative 10. This is 1 over 10 power 10, which is still value. But what if x is negative infinity? So log 10, this is negative infinity. So to find out what is this value, the y value, think this way, y is now 10 power negative infinity, which is 1 over 10 power infinity. And 1 over 10 power infinity is infinity, 1 over infinity is 0. So what I'm saying is that if you put log 10 0, you get negative infinity. So it's actually impossible to find log base 10 0. Yeah, if you try to type this in a calculator, by the way, in this calculator, this is log base 10. This calculator, this LOG here is log base 10. You type log 0, you get math error. Now, that means what we have here is this: the smallest possible value of the y value that you're going to put inside here should be 0. Okay, in fact, 0 also cannot include that. You can say that y must be more than 0, because if you try to put log 10 of a negative number, let's say negative 1, what do you get? Math error. Because it's impossible. The smallest value of possible y, the possible value of y is just 0. If you put negative infinity, this will be 0. The rest can never be less than 0, right? So if you try to log any number, generally we say that if you get log 10y or even any base, your y value is always more than 0. Okay? Always positive. You cannot log negative number. You try negative 1, math error. Try negative 3, negative 5, math error. Even 0, you get math error. Okay? Now, moving on. Another thing I need to talk to you about is this natural logarithm. Okay? Now, okay, I don't want to go through the details because you don't need to know this. That the base e, this is exponential base. Yeah, you're familiar with log base 10, log base, other bases. There's a short form to log base 10 though. It's called LG. LG stands for log base 10. But we also have another base called base e. Now e is a constant, 2.71828 and so on. It goes on. You can find e here actually. So you have a calculator. You can see there's a log. This is pronounced as ln. This means log base e. Ln, natural logarithm ln. So you press shift ln. There's an e here, right? You press 1. This is e power 1. You get this constant 2.71828. Yeah. Now, this constant you can actually define by using the limit, but like I said, this one you don't need to know for now. Okay. So, natural logarithm is something that we commonly use to model things in what do you call that, in our daily life. Like for example, you talk about human population growth. We can represent it with this function. The growth of your coronavirus, the mortality rate, and things like that. Right, we can actually use that. Okay. Anyhow, so you can find similar to log base 10. You can find this by typing this as log, say 2. You get your value. Okay. Log base 2 simply means that log base e. ln2 means log base e of this number 2. So e power what is 2? Okay, answer 0.693. That's the meaning. Okay, so again, you cannot ln 0. You cannot ln negative 1. Yeah, by the way, we pronounce this as ln. Okay, I think we go straight to this. Now we're going to do some calculation. Using a calculator, find the values of log 15. LG, log 15, like this. What do you get? 1.18. The second one, ln 6. 1.79. Okay. Okay, for chapter 6, I'm going to find log 274. First answer 2.44. Okay. My second answer ln 0.7, negative 0.357. Okay, your index can be negative, right? Just so you know, when we talk about when you ln or log, you can get a negative answer. In fact, do you know that if any number, either log or ln, let's say for example, and your y value, let's say, is any number between 0 and 1, the logarithm of this is always negative. Yeah. So you can take log of 0.5, you get negative. Yeah. Ln of 0.9, you get negative. Okay. Power log 10 3, since they have the same value, the result is just 3. Now for the second one, e, right, I need to write e ln 2. Now here you have a few options. Right? Option 1, you take out the negative 3. E ln 2 will give us what? 2. So this 2 power negative 3, which is 1 over 2 power 3, or 1 over 8. Right? Now option 2, you can also do it this way. Instead of taking out the power 3, right, we bring this up, write this as e ln 2 power negative 3, which is actually e ln 1 over 8, isn't it? 2 power negative 3 is 1 over 8, right? And the result is still 1 over 8. Yeah, you can choose to take out the power negative 3 first, or you bring the power up. Now the third one, I need to split this first. 2 power 3 plus 2 log 2 7. Okay, so I made a mistake here. Sorry, this should be a multiplier. Remember, in laws of indices, we learned this earlier, that a power m plus n is actually a power m multiply a power n. So this is 2 power 3 times 2 power log 2, 7. You get 8 times 7. Answer 56. Guys, the first thing I need to do is to change this directly. E log 5 is just 5. This one is up to you. Some of you prefer to bring the half outside. So this is 4 power half, and 4 power half is 2. Okay. Now, for those who transfer the power up, this is 4 power half. So which is 10 log 10 2. The result is also 2. Okay, for C, I'm going to divide 3 power 4 divide 3 power log 3 10. 3 power 4 gives us 81. 3 log 3 10 is 10. The result is 8.1. Okay. Can you say 50 is 2 power anything? The closest I can get is 2 power 6 is 64. 2 power 5 is 32. So I know the answer should be 2x should be 5 point something. But we cannot find exactly what it is. So this is where we can use the concept of introducing log on both sides. Okay, here's the thing. I need to explain to you one concept that is in logarithm, right? X power x. That means LG2. The result is LG50. Yeah, the power 2x you can bring it down. If you want to know why, I can explain to you, but sometimes the derivation is making you guys more confused. LG50 to LG2. Can you help me? Use your calculator. Okay, guys, sorry. Let's count. Now, I just need to warn you, this calculator, because some people use log 50 over 2 log 2 is wrong. This calculator will go and do 50 divided by 2 first. Yeah, so you should use the symbol divide instead of over, right? So your answer is 2.82. Correct. Yeah. If you have a silver one, or this one is better actually in a way. But this calculator has one handicap because the log is not here. The log is on this side. Anyone using this one? Nobody is. The log is on this side. Yeah, you have to press shift log. Then you take 50. Then you divide shift log. And 2, there's a 2 in front. Okay, so look it up. Answer 2.82. Okay. Right. Now the second one, right now, when you have x on the left and on the right hand side of the equation, that means you got double. You don't want to introduce log too early. You're making it more difficult for yourself. Yeah, you can use laws of logarithm. Some of you already learned laws of logarithm, but it's harder. For me, I will arrange this equation such that I put all the x on one side, all the rest of the number on the other side. You know this, right? 11 power 1 plus x is 11 power 1 times 11 power x. So I'm going to bring the 11x down. So this 3 power x, 11 power x, the result is 11 over 5. And this one, I can combine it, right? And I can introduce log, yeah? Okay. So you want to bring the power x down. This is 11 over 5. Okay. Now we take log 11 over 5, divide log 3 over 11. The result is negative 0.607. Okay. Now the first thing is when you have a single x, it's very simple. We just introduce log on both sides. Okay. Number 2, you bring the power x down. Yeah. Okay. And number 3, we just transfer this. Log 100 is actually 2. Log 100 divide log 5, 2.6. Okay. The second one now. You cannot multiply first. You should break this up. Okay, now I would bring the 2x down. Yeah. So you get 3 over 2, 7x over 2x. Now these two we can put together as 7 over 2 power x, and this is 3 over 2. Okay? Cannot. We take out common factor. What's a common factor? X. Now, only then we introduce log. That will be much easier. Then you bring the power down, yeah, and use your calculator. Log 3 over 2 divide log 7 over 2. The result is 0.324. Okay? Here we introduce ln on both sides. Okay, there are two ways. One is we convert directly to exponential logarithm form. Okay, some of you may be able to do it directly. Some of you may think it's easier if you introduce ln. Now, one of the ways, this is index form, right? If I change to logarithm, we write log base e, right? What's the number? Y. What's the base? E. What's the power? X. So basically, x is ln y. I show you again. I don't write anything first. If e power x is 2, x is ln 2. Can I not? If e power x plus 1 is 3, x plus 1 is ln 3. If e x squared is 4, x squared is ln 4. Can you do it directly? Yeah, this is one way. Another way, some people find that this is difficult. They find it's confusing to convert directly. Then you can also do this. You introduce ln on the left, introduce ln on the right. Then you bring the power x down. You get x ln e. Now everybody, x ln e gives us, what is ln e? Ln e is 1. Okay, I forgot to tell you, log 10 has a value of 1. Why? 10 power 1 is 10. Log 5 has a value of 1. Why? 5 power 1 is 5. Log a is also 1 because a power 1 is a. So ln e is also 1. Ln simply means log base e because log e power 1 is e. Cannot. So you can choose to introduce ln, bring the power down, and write x equals ln 2, but you have to do extra step. Or if you are, can you do it directly? You think you all can do this directly? I'll give you another example. E power 2x minus 1 equals to 5. So what do you write? 2x minus 1 is ln 5. Then you slowly bring a 1 over divided by 2, right? Okay, so I'm going to do this, right, guys? We're going to write this as x equals to ln 5. And now you type this in your calculator, everyone. Ln 5 is 1.61. Okay, the second one I'm going to divide first. Ex minus 2 is 7 over 4. X minus 2 is ln 7 over 4. X is 2 plus ln 7 over 4. Help me, 2 plus ln 7 over 4. The result is 2.56. Okay? Yes? One, x is ln 8. What is ln 8? Anyone? 2.08. The second one, divide by 2 first. So you get 9 over 2. 3x is ln 9 over 2. X is what? Ln 9 over 2 divided by 3. Somebody? 501. Okay? Okay? Now, I need to simplify this first. Now, because you see, unlike, I just want to clarify this. There are 3 types of initial equations so far. The first one is what? If I give you 3 power x equals to 27, can we say 3 power x equals to 3 power 3, x is 3, no problem, right? But if I say 3 power x equals to 20, can you tell me 20 is 3 power something? No. So we have to use ln or log. Yeah? So then you bring the power down, and then you use a calculator and divide. Okay? Now, what if I have 3 power x plus 1 equals to 3 power x, and then let's say this is 54. Now, you cannot introduce log because some of you say, oh, I introduced log like this. You see, unlike a equals to b plus c, can I say a squared equals to b squared plus c squared? Wrong. No. Example, 3 plus 4 equals 5. Can I say 3 squared plus 4 squared? Oh, sorry, 3 plus 4 is 7. Can I say 3 squared plus 4 squared equals to 7 squared? No, 3 squared plus 4 squared is supposed to be 5 squared. Right. So you cannot square individually. It's wrong. But we can square the whole thing. For example, A equals B plus C. The right thing to do is this. This is true. You square the whole thing. Similarly, if I say A equals B plus C, can I say log A equals log B plus log C? No. Why not? Example, we know that 5 is 2 plus 3. Can I say log 5 equals to log 2 plus log 3? No, because log 2 plus log 3 is actually log, some of you already learned this, it's actually log 6. So this is not the same, right? So the only thing that's true is log 5 is actually, log 5 is log 2 plus 3. This is true. Like A equals to B plus C, log A is log B plus C. This is true. You want to log, you log the whole thing. You want to square, square the whole thing. Cannot do individually. Understand? Huh? A lot of people tend to make this silly mistake. They square one by one, and they think it's equal. They log one by one, they think it's the same. So you cannot use logarithm like this. So, and if you try to log the whole thing, everybody, you try to log the whole thing, what can I do with this? There's nothing. You cannot break this up because they are together. So the way in which to solve this type of question is that we have to use substitution, as the question suggests here. So, but before you substitute, you need to break this up. This is 5 power x times 5 power 1. This is 5 power x divide 5 power 1. Yes? Hello? Now, I need to let 5 power x becomes u. Yeah? Substitute with u, let's say. So this will become how many u? 5u. This is 6 plus u over 5. Now next I need to simplify this. Now how do you simplify this? You multiply everything by 5. So when I times with 5, this will be 25u equals to 30 plus u. Cannot. Multiply by 5, multiply by 5. Everybody must times 5. Okay. Next, I bring this over. This will be 24u equals to 30. U equals to 30 divided 24 is what? 5 over 4, right? Okay. Now, u is 5 power x. This is 5 over 4. We cannot solve this, right? Can we? If I get 5 power x equals to 25, yes, then I can change 25 to 5 power 2. You can't. So we introduce log. Bring the power down. Use your calculator. Somebody log 5 over 4 divide log 5. Okay, I think I use my calculator. Log 5 over 4 divide log 5. Answer? 0.139. Okay? Yes? Bring this up. 2 power x divided 2 power 1. This is 15, 3, 2x. So you let 2 power x becomes u. This will be u over 2 plus 15, 3u. Okay? Now again, I don't like fraction. So I think it's easier if you multiply everything by. So when I multiply by 2u plus 30 is now 6u. Bring over 5u is 30. Right? U should be what? 6. But don't stop here. Why? What are we finding? You're finding for x. So we sub inside. Introducing log. Actually, you can use log, you can use log. Log also can, but I think most of us are more familiar with log. So I bring the power down. Log 6 divided by 2.58. Yeah. Okay. 11 is quadratic. So before we substitute again, let us break this up. 2 power x, 2 power 1. This is 3. For me, I'll write this as 1 over 2x. Because 2 power negative x is 1 over 2 power x. So by substituting this with u, I get 2u, 3 over u equals to 5. Multiply everything by u, 2u squared plus 3 equals 5u. Bring over 2u squared minus 5u plus 3 equals 0. Let us double bracket factorize. I use 3 and 1 minus and minus. So am I right? This is 2, 3 is 5. So u is 3 over 2, u is 1. So you introduce, replace this back. Yeah. Okay, for me, this one, 1, can I write 2 power 0 straight away? 1 is 2 power 0, right? Yeah. This one we cannot solve using comparison. We cannot change 3 over 2 to 2 power anything. So I have to introduce log and log. Bring the power down. Help me, please. Log 3 over 2. Divide log 2. Yeah, 0.585. The second one, by comparison, x is 0. Okay. The thing is, you need to break this up. 9 is 3 power 2x. This is 3 power x, 3 power 1. Okay, you want to switch this. The reason why I switch the position is because I want to substitute 3 power x with u. So this is 3x plus 4. By replacing this with u, I get u squared, 3u, 1 minus plus. So you notice by now that anything power x is always positive, always more than 0. Okay, let's say this again. Anything power x is always more than 0. For example, what is the smallest value you can ever get? What is the smallest possible value of x you can ever get? Answer, negative infinity. So let's say I have 3 power negative infinity. Power negative means 1 over. What is 3 power infinity? Come on. Anything power infinity is? Infinity. Right. You don't believe me. What is infinity? It's a very large number that I don't know exactly. Okay, sorry, you get math error. It's a very large number, right? So, and what is 1 over infinity? 0. No. Okay, I have. Okay, if you want to understand infinity, right? Like, what is 1 over 10? 0.1. What is 1 over 100? 0.01. What is 1 over 1000? 0.001. What is 1 over 1? 0.00000. You get 0.000. The number is getting smaller or bigger? It's getting smaller. So when I take 1 and I divide a very large number, you get a very small number, almost 0. For example, I have a candy. I want to share with 7 billion people. So 1% gets how much? Nothing. Particles are too small. You can't even get, right? So likewise, because of that, 3 power x is always more than 0. Yeah, I put infinity inside, I get infinity, 1 over infinity is 0. So it's always positive. So we ignore this, we take the second answer. 3 power x is 4. Introduce log on both sides. So you want to bring the power down, and x will be what? Log 4 divided by log 3. Answer, log 4 divided by log 3, 1.26. Here we have exponential, ex multiplied over e power x plus 2 is 3ex minus 3. Yeah, that is step 1. Step 2, bring over, this is 5, this is 2ex, yes. So from here I divide by 2, ex is 5 over 2. Okay, now for me I would change directly from exponential form to logarithmic form. This is ln 5 over 2. Can you help me out? Ln 5 over 2 is just 0.916. Okay? This one. Multiply inside first. 3 power. Now ex times ex is e2x. This is 2 ex equals to 8. Now before we substitute, I think it's best I put in this form. Some people can or should I factorize directly? You think you can factorize without substitution? Okay, I changed my mind. I hope you can. You don't have to put u, right? Do I have to write 3u squared minus? No need, right? No need, can. So we're going to factorize this directly. 3 times 8 is 24. What's the factor of 24? 6 and 4. Alright, so this is 6. This is 4. 6 is negative, 4 is positive. Yeah. If you cannot, then you write 3u squared minus 2u minus 8. Then you factorize this way first. 3u plus 4, u minus 2. Then you expand. Okay, expand. I mean, you substitute back. Yeah, you find your u and then substitute back. Okay, in this case, ex is negative 4 over 3. Now we know this cannot happen. Huh? Anything power x must be more than 0. So we take ex equals to 2. And to solve for x, what do I do? I change from index form to logarithm form. Ln 2, somebody ln 2 is 0.693. Okay. We want to bring this over to ex equals to 7. Ex is 7 over 2. X is ln 7 over 2. Tell me. Ln 7 over 2 is 5.25. Sorry. 1.25. Hearing problem. So the second one, you want to change this to 6 over ex. You can multiply everything by ex. Now, if you think this is complicated, you can use substitution. Let e power x becomes u. How many of you use substitution? Okay, 1%, 2%, 3%. Yeah. Okay, now I show substitution. U equals to 5 plus 6 over u. Substitution in a way is easier to see. This is 5u plus 6. Bring over. Then we double bracket, factorize them, 6 and 1, right? Minus and plus. So u is negative 1 and u is 6. Now we know e power x cannot be negative 1. So e power x must be 6. X must be ln 6. And ln 6 is? So 9. Thank you.